So let's make back a start. So we said we are going to talk a little about quadratic expressions and equations, right? So let's start with what we mean by a quadratic expression, right? So as you can see here, quadratic expression is of this form. Yeah, it's of this form here, right? Um, yeah. As you can see here, it's an expression of this form, right? You can see quadratic expressions that doesn't have this term nor this term inside, right? But you must have a term where you have an x squared term, right? Because you can have an expression like this, y equal 2x squared. That's a quadratic, right? A quadratic. Y equal x squared. That's still a quadratic, right? Now, why is it they call it a quadratic? Because usually, it's a product of two binomials. Binomials mean two, right? This is a algebraic expression with two terms inside, one here, one here. So you call it a binomial. This one is also a binomial, right? It has two terms inside. And the product of two binomials is what we call a quadratic, right? So just like how you say 2 by 2 equal 4, right? Binomial by a binomial gives you a quad. Notice 4 quadratic. And when you simplify it, you usually end up with 3 terms like this, right? I know you see in 3 terms, you say, how am I going to call it in quadratic? I'm not seeing 4 terms, but it simplifies to give you often 3 terms, right? Yeah, so that's basically what a quadratic is, right? So that's a little introduction there to that structure, right? The quadratic expression, what it looks like. Now, what we're going to talk about in this particular lecture here, we're going to talk a little about how we can solve quadratic equations by first factorization. We're not going to cover this in this course, right? We're not going to cover this in this course. And then I'm going to talk briefly about the formula, because this is very useful for you when the factorization method fails, because it's sometimes some quadratic equations can't factorize, or it can't factorize simply. And therefore, we have to resort to either completing the square or the formula, right? And I guess for this course, I notice your course outline doesn't include completing the square because maybe the level of abstraction might be, I don't want to use the word too high, but maybe unsuitable, right? And therefore, the formula, it works every time, right? Works with any equation, and therefore knowing the formula is a powerful tool. Now, before we can actually solve quadratic equations by factorization, we got to know how to factorize, right? So let's start with that. Let's talk a little about factorization. So look here. So here you have a quadratic, 2x squared plus 3x. You have another one there, minus 2x squared minus 6x. And they ask you to factorize by removing a common factor. Now, before we answer these two questions, right, the A and the B part, let me just show you where this whole idea of factorization came from. And you will remember I introduced something called the distributive law. I'll write it here, the distributive law. Right? And the distributive law is saying that when you have a number in front here, it's multiplied by everything in this bracket. Basically, that is equal to AB plus AC, right? You multiply what is in front of the bracket by everything in the bracket, right? Good. Now the factorization process is the opposite. We are used to removing brackets and getting this. But in the factorization process, what we're doing, we are taking the common factor A outside. You notice that? And you're dividing AB by A and you get B. Then AC by divided by A gives you C, right? So it's the opposite of the distributive law, right? You are actually not removing the bracket, but you are inserting the bracket. You are removing that common factor and putting it in front, right? And that's what we're doing here now. That's what we want to do here. We want to factorize 2x squared plus 3x. What's the common factor? What is it that we can divide 2x squared by and 3x? Can't be 2 because 3 can be divided by 2, right? When I say 3 can be divided by, I mean it's no remainder. That's what I mean, right? Good. Now, the only thing that is common there is x, and therefore, notice we are using the distributive law. We take x to the outside of the bracket. 2x divided by x gives us 2x. 3x divided by x gives us 3. And we finish with our factorization, right? Look over here. And tell me if you're not following, right? We have to factorize minus 2x squared minus 6x. So we're looking for common factors. And notice they're asking for the highest common factor. You would notice though in this time, even though it's a highest, we still use negative 2. Notice we use negative 2x, right? And I think that term highest now can now be misleading really, right? The term highest common factor. Sometimes you think, wait, why we didn't use 2, right? But you will see later on, and as we go on into this thing deep, you'll see taking out the negative very often is advantageous, right? So even though we're looking for the highest common factor, you're not taking out 2x, but we're taking out negative 2x. So negative 2x squared divided by negative 2x will give us x. Negative 6x divided by negative 2x will give us 3. Right? Y'all follow how I get that?
Yes, sir.
For those who wonder, okay, how do I, let me go back to this portion. How do I divide 2x squared by x and get 2x, right? You can put it like this. 2x squared divided by x, right? Now this is the same as 2 times x, all divided by x. This x into x is 1, x into x is 1, and we are left with 2x. See, and that's where we got this 2x. 3x divided by x, you can go up here, 3x divided by x into x1, x into x1. And you're left with 3. Understand? And that's what we do the other side as well, right? With the b part. Follow so far?
Yes, sir.
Now, here is a nice rule that helps us to factorize what we call difference of squares. Whenever you have when you have an expression, a quadratic expression, that is in the form of a difference of squares, you can factorize using this here. Okay. So whenever you see a quadratic expression of the form a squared minus b squared, that factorizes to give you a plus b, a minus b. Right? That's an identity that you can quote and use. Now let's look at an example. You have 9 minus x squared, and you have to factorize that. And then you have 4x squared minus 25. So when you look at this one, 9 minus x squared, let's go to that one, right? That's this part here. You can recognize that 9 is really 3 squared, right? So now it resembles this expression here. A is like the 3 and B is like the X. So where you see A and B here, you put 3 and X. Where you see A and B here, you put 3 and X. So that factorizes to give you 3 plus X, 3 minus X. Right? So we're making use of this identity here. Look at the second one. Tell me if you're not following, you want me to slow down. You have 4x squared minus 25.
My Wi-Fi, so I didn't get to hear what you said just now.
Want me to go back from the beginning?
No, sir. The last thing I heard was the 3 by 3, 3 square.
Okay, yeah. All right. We're factorizing 9 minus x squared. At first glance, what's happening here? My pen, yeah. At first glance, this doesn't resemble that exactly. Doesn't resemble that exactly. You're seeing an x squared that seems to match the b squared, but 9 doesn't match the a squared. But you know that 9 is the same as 3 squared, right? So we're writing back 9 as 3 squared. Now it does resemble that. Look, 3 squared resembles the a squared. X squared resembles the b squared. So we can apply this rule that a squared minus b squared is equals to a plus b, a minus b, right? So our a is like 3 or b is like x. So you just got to fill in 3 in the place of a, that's what we got here. X in the place of b, and that's what we got here, over here. A in the place of, 3 in the place of a, and x in the place of b. And it's done. Look at the second one. When we look at this here, we have to be careful with this one, right? Now, you can't assume that a is 4x, right? A is not 4x. Because if you notice here, this square doesn't govern the 4. It only governs the x. However, you can write 4 as 2 squared, isn't that so? You can write 4 as 2, right? And if you square 2, you will get that 4. See that? So instead of writing 4x squared, you write 2 square x squared. This can be written as 2x all squared.
Sir,
yeah.
Well, I'm going back to A, right?
Yeah.
3 square is actually 3 multiplied by 3.
Yes.
Multiplied by 3. Because 3
multiplied by 3, yeah.
Are you multiplying it 2 times or 3 times? Because I don't know if I understand it clear.
You multiplying 3 by itself. That's what 3 squared means. You got that?
No.
3 squared means 3 multiplied by itself.
Which is 3 multiplied by 3.
Yes. Got it?
Yeah.
Good. So let's go back to the B part, right? As we mentioned, this doesn't match that exactly, because this 4 isn't governed by this square, right? That means this 4 multiplied by x squared. So this 4 isn't governed by that x, but we can write 4 as 2 squared. See? So now because this 2 and the x are both squared, we can put the 2x in a bracket and square them all. So this 2x now matches up this a, right? And of course, well, the square matches up the square on top there, right? Similarly, we can take this 25 and we can write it as 5 squared. So the 5 matches up with the b. The square matches up with the b square, right? The square on top there. And now we can apply the rule here. So a, this is like a, and 5 is like the b. So it's a plus b times a minus b, right? 2x plus 5, 2x minus 5. And that's how you apply what we call the difference of square rules, rule to factorize certain quadratics. Not all, well, remember, not all quadratics are difference of squares. There's some that are like that. Some more examples that, well, these kind of stretch difference of squares a little further. Look at this one. 2x squared minus 8. That's this one here. And then you have this one here, minus 3x squared plus 40. At first glance, it doesn't seem at all that these have anything to do with difference of squares, right? But sometimes, you know, as we analyze the problem, you will see that, yes, we can actually make use of this difference of squares formula to factorize. Look at what we do with this first one. We factorize out 2. And when we factorize out 2, we get what? 2x squared divided by 2 will give you x squared. Minus 8 divided by 2 will give you minus 4. Now, this here inside here is now a difference of square, right? Because, well, x squared is a square and 4 is 2 squared. So we can now factorize inside here using the difference of square formula. See? And we get this. Follow that one? Look at the second one. Again, it doesn't look like this has anything to do with a difference of square, right? However, if we were to factorize out minus 3, inside here we'll get what? Minus 3x squared divided by minus 3 will give us x squared. Positive 48 divided by minus 3 will give us minus 16. Now it starts to look like a difference of squares indeed. So minus 16 now can be written as minus 4 squared, right? So we now have a difference of squares inside there. We further factorize it and we get that. See? So that's taking it a little further, you know? I'm not going to go more in depth with difference of squares. It goes much further than that, right? Good. So this is a more general way of factorizing quadratic expressions, right? So you have this quadratic expression to factorize. 6x squared plus 19x plus 10, right? We have this here. This, we want to factorize that. This is a very general method. I want you to follow it very carefully, right? It's a systematic approach to factorizing. It works almost for any quadratic expression that can be factorized, right? Not all of them will lend themselves to factorization, but the ones that do, this will work. Good. So this is what you do. You'll take the number in front here. Yeah. The number in front here and the number in the back here. And you multiply it. So we get 60. And then we look at this number that is the coefficient of x, the number in front of x. We got 19. What we're going to do, we're going to look for two numbers. When we add them, we must get 19. That's the number in front of x. And when we multiply these two numbers, they must get what we call the AC number, right? 6 multiplied by 10, that is 60. So we're looking for two numbers. When we add them, we must get 19. And when we multiply them, we must get 60. Now the people help us out here and they say, look, 4 and 15, when we add them, we get 19. And when we multiply them, we get 60. Now, here is what we're going to do with those two numbers. We're going to write back 19x using the 4 and the 15. Because 4x plus 15x is the same 19x. So we haven't done anything to the expression. We simply split. Or in other words, we haven't altered its value. Right? All we did is write 19x in two parts. And we did it for a reason. Look at what is going to happen. If I take these two and I take these two and I look for the highest common factor of this pair is 2x. 6x squared divided by 2x gives us 3x. 4x divided by 2x gives us 2. Right? I do the same thing here. I take here and I look at, well, what's the highest common factor? We take out 5. 15x divided by 5 gives us 3x. 10 divided by 5 gives us 2. As a matter of fact, whenever you're doing this, you always want to have this bracket being the same as this bracket. As a matter of fact, you don't even have to worry about what is going to be in this bracket. You could just write back this bracket here and then ask yourself, what do I need to multiply 3x by to give me 15x? It's 5. And you will find that, well, the same is true of this 2 here. What do I have to multiply 2 by to give you 10? It's going to be 5, right? So that's another way of looking at it. Now, we're applying now the distributive law in another way now. Watch here. When we had, let's say you have AB plus AC. That is equal to A bracket B plus C. In other words, you take the common factor out to the front and you put the B and the C in a bracket. Well, look here, isn't it similar? Watch here. 3 plus 2 is common, just like the A. So we're taking the 3 plus 2 outside and we're putting the 2x and the 5 in another bracket, just like we're putting the B and the C in another bracket. Right? Sorry about that. I got bumped off. There was a blackout. Give me a second to get back my slides and so. Give me a second. I just want to get back where I left off on the slide. Yes, so I was illustrating the general factorization using this example. But I have a few more that we can actually use. Look at another one. Notice here you have the quadratic 3x squared minus x minus 10. So we're going to take this 3 and this minus 10. We're going to multiply them and you get minus 30. So you're taking the coefficient of x squared and the constant at the end and you multiply them. And then you're going to also take the coefficient of x here, which is minus 1. What we're going to do, we're going to look for two numbers that when we add them, we must get minus 1. And when we multiply them, we must get minus 30. So it happened that those two numbers are 5 and minus 6. Right? And sometimes that takes some doing, right? That takes some doing. So you might want to know, how come we come up with those two numbers so fast? Well, here's where experience comes in. You're being able to do a lot of these and it becomes second nature. Lots of times you look for factors of the 30, right? Or the AC number. You look for factors of minus 30. Don't only think of positive numbers, right? Think of negatives as well. So when we add 5 and negative 6, we will get our minus 1. And when we multiply it, we're going to get our minus 30. So we're going to write minus x in terms of that 5 and minus 6, right? Okay. We're going to write it as 5x minus 6x, which is the same as minus x, right? We're going to now take these two together. But if we were to put these two in a bracket, we have to change this sign, right? To a plus. Because when we remove the bracket, this minus and that plus will become a minus, right? So when I put a bracket around here, this sign has to change. Now we're going to factorize them. We're going to look at what's common here, x. 3x squared divided by x gives us 3x. 5x divided by x gives us 5. 6x, but again, as a matter of fact, you don't have to wonder what must go in this bracket. You write back the same bracket, right? So you can write back the same bracket here. you just ask yourself, what do I have to multiply 3x by to give me 6x? Not 2, right? So you just have your 2 there. And of course, this sign remains the same. Alternative to that, you can look at what is the highest common factor here. It's 2. 6x divided by 2 gives you 3x. 10 divided by 2 gives you 5. Now, because these two brackets are common, we pull them to the front and we put this and this in another bracket. And we're done factorizing. And this method works for any expression that, that you can factorize. It works for anyone. Now, why are we learning how to factorize? Why are we learning that? Well, the simple reason is that there is a certain idea we can make use of. And that idea can help us to solve quadratic equations. Now, what's that idea? Here is the idea. The idea basically is saying that if two numbers multiply to give you 0, then either this number is 0 or the other number is 0 or both of them are 0. So if two numbers multiply, if these two numbers m and n, they multiply to give you 0, then either one of them is 0. Now, what is the use of that really? What is the use of that? So in other words, if you factorize a quadratic equation, so you have a quadratic equation. Let's say you have x squared plus 5x plus 6 equals 0. And you factorize this. When you factorize it, you get x plus 3, x plus 2, right? I'm not going to show you all the steps. So you factorize it. Now, this bracket is like the m. This bracket is like the n equals 0. So just like how you would say, all right, if mn equals 0, then either m is equals to 0 or n is equals to 0. So we can apply it here. If x plus 3 by x plus 2 is equals to 0, then either x plus 3 equals 0, which means that I take the 3 over there, x equal minus 3, right? So we got a value for x, or x plus 2 is equals to 0. That implies that x equal minus 2. So here it is, this idea of if two numbers multiply to give you 0, then one of the number must be 0 or the other one must be 0. And we're making use of that idea to solve this quadratic equation. But before you can solve the quadratic equation, you notice we have to factorize it. We have to write it as a product of two factors. Only then the reasoning works. Right? And let's look at some examples here. Look at this one. So you have to solve the quadratic equation, and notice you have to put the quadratic equation. You have to rearrange it so that it equals 0. In this case, it's already equal to 0, so you don't have to worry. When it's not equal to 0, you have to rearrange it. Bring everything to one side, simplify, make it equal 0. So you have the quadratic equation x squared minus 6x, right? So when we factorize that, what do we see? We see that, well, it factorized, you see x being common, right? So you pull the x to the front. X squared divided by x gives you x. Minus 6x divided by x gives you minus 6. So it's already factorized. So this is like the m and this is like the n. So it's either x equals 0 or x minus 6 equals 0. Well, you already got a solution here. Or x minus 6 equals 0. And if x minus 6 equals 0, you take the 6 over there. x equal to 6. And you got two solutions. See? You follow so far?
Yes, sir.
Okay. Let's go to another. So here you have a difference of squares now. You have x squared minus 9. You remember this from earlier? So we take the x squared minus 9 and we factorize it. So we did this, so we don't have to go through it again. We use the difference of square formula, we get that, right? And we use the same reasoning. You take one bracket, put it equals 0, solve for x. Then you take the other bracket, put it equals 0, solve for x. And those are your two solutions, right? Answer, x equal minus 3 or 3. Simple enough? Good. So I'm going to skip over I'm going to skip over this matter of completing a square. And I want to go straight to the quadratic formula. I know this might look fuzzy to you. What this basically is this. If you have an equation of this form, oh, the 0 gone over here, it should be here, right? X then is equals to minus b plus or minus the root of b squared minus 4ac all over 2a, right? So if it's fuzzy for you, that's the formula, right? And this is all over. You won't have to memorize this formula because even in your final exam and all, this is, you can write it down some corner of your book, right? How do you use the formula? That's what I'm interested in. How do you use it? Let's look at an example. So look at this one. You have to solve the equation. You have to solve the equation x squared plus 3x minus 4 equals 0, right? So you got to identify, well, okay, you got to identify, well, what is a, right? This equation is of the form ax squared plus bx plus c. So a is like this 1 in front here. B is like this 3 here. And c is this minus 4, right? And you put it in the formula. So the formula, remember, is x equal minus b plus or minus the root of b squared minus 4ac all over 2a, right? So a we said is 3, so b is 3, so it's minus 3 plus or minus 3 squared minus 4 times a times c is minus 4 all over 2a, which is 2 times 1. And you simplify, right? You use your calculator, you simplify. That whole thing under there turns out to be 9 plus 16, which is 25, right? Now this here, remember the square root of a number is both the positive square root and the negative square root. So the square root of 25 is not just 5. Square root of 25 is also, square root of this 25 here is also, it's positive 5 as well as negative 5, right? So x then can either be, okay, you take the minus 3 with the negative over 2, then you take minus 3 at the positive over 2. When you simplify these two, you will get these two numbers. You get minus 4 and 1. Follow that one? Let's take a last example. Look at this one. So you have 2x squared minus 4x minus 3 equals 0. So you got to figure out what's a, what's b, what's c, right? So a is this 2 here. A is this 2. B is -4, C is -3. So you put in the formula, X equal minus B, but B is also minus, right? So -4 plus or minus the root of -4 square -4 times A, which is 2, times C, which is -3. When you simplify that, this whole bottom here, you will get 16 plus 24, which is 40, right? This minus by that minus become a plus, so you get positive 40, right? 2 by 2 is 4, simplify, simplify. Well, here, you can use a decimal. Square root of 40, don't worry with this. You'll get a decimal from your calculator, right? And you can work it out, you will get these answers here. Don't worry about all of this with this, we'll call a square root or a sword, right? You'll get some nice, you'll get, not nice, but you'll get 2 decimals. In the notes, I think there'll be a couple more, I think trying to remember if I gave you some more examples inside. Good, so what we'll do, we'll pause there on quadratics. I'm gonna go into more on quadratics. I think I sent you some questions to try, right? So please try those.